This is question number 9 of homework 5 for chapter 5. So this is question about annuity deal, how to calculate the sort of the present value, I believe the present value of annuity deal. We know that ordinary annuity means that the first payment will start 1 year from today. Annuity due, in contrast, means that the first payment will start immediately. So here we know that the 2 million here should be understood as the present value of this annuity due, and that's why here, even though you only have 24 years, but actually have 25 payments. So going back to our book or the lecture slides, we should understand that this n, which is the number of periods for which the annuity will last, actually should be the number of annuity payments. Because if you note the note I made in red font here, you should understand that that's the case. So basically, n is the number of annuity payments. But this formula actually is just for the present value of ordinary annuity. An annuity deal is that after you get this amount, and then you just multiply by 1 plus the interest rate. So basically, you just need to compound the annuity compared with the ordinary annuity. Annuity deal is just compound for 1 more period if we calculate the future value, or we just discount by 1 less period if we are calculating the present value. So that's what we are doing here, the present value. So that's basically the relationship between these two. And you can also find that relationship from my PowerPoint lecture slides here. All right, so going back to this question, we know the annuity payment, and we know the number of payments, right, 25, and we know the discount rate. And then what is the present value of the basically annuity due? So to figure that out, I just use the present value formula in Excel, right? Again, I would like to use Excel because that's the most convenient way for me, at least, to figure out the answers. Also, I like to use Excel because it has many built-in functions to do the financial calculations. So here, like example, we can just use PV function, which is built in by Excel to calculate the present value of sort of, you can take this as any even a single cash flow or a stream of cash flows such as the annuity we are doing here. So equals PV and open that. And then just need to notice the rate here. The first argument here is the interest rate, right? That's the 7%, and that's also the discount rate, 7%. So the number of NPER here, again, this means the number of annuity payments. So that's 25. And the payment, PMT, stands for payment. Payment is $80,000. So, and if I just leave it like this, then the rule in Excel or financial calculator is that I will get a negative present value. So if I want a positive present value, then I can just put a negative sign in front of this payment. And that's what I choose to do here. So, and then I can close this now because you can see that all other arguments are optional and they are sort of by default. Is we don't have to change that because they conform with the default values. So for example, the FV stands for the future value. Here we don't have the future value for the annuity, and type stands for, well, actually, I think I made a mistake in saying that these two can be omitted. Actually, the default for the type stands for beginning of the year or end of the year convention. So if it is an ordinary annuity, then we should use the end of the year convention. That's the default. But since this is the beginning of the year, so that's the annuity due, right? Beginning of the year convention. Actually, we need to do something there. Of course, this is one way to get the final answer. So 0, that's the future value. And then after that, the type, once you get into the type here, you can see that 0 stands for the end of the period. That's the default value for type. And 1 stands for the beginning of the period. So actually, in this case, we want to change this to be 1 rather than 0. So once you do that, you can get the present value of this annuity due by directly using the present value formula or function in Excel. But there's another way to get the same answer, which is still to use the PV function, and the interest rate or the discount rate will be the same, right, 7%. And NPER will also be the same as before. And payment, I also keep this to be negative, $80,000. And here I don't want to worry about the type, right? Which means that Excel will assume this is the end of the period convention. But this is not what we are doing here, right? What we are doing here is actually an annuity due, but end of the period means that it's an ordinary annuity. But once we have the present value of an ordinary annuity with all the characteristics the same as the annuity due, and then we know their relationship is that we need to multiply by 1 plus the interest rate. So you can see that these two will give us exactly the same answer. So and the reason we got different answers is because you can see this is in percentage format. So what I want to do is just to change the format of the cell here, and just change to the number and probably just keep 2 decimal places. And now you can see it's exactly the same as what we got above. So whichever way we use, we got the same answer. Just copy that number back to MyLab and check my answer here. And I guess the part B is similar. I just need to probably do some adjustment here rather than start a new calculation. So rather than having a discount rate of 7%, now I have a discount rate of 14%. I guess that's the only change we need to do here. And once you do that change, you can see this amount will also change. So obviously a higher discount rate will drive a lower present value, and that's basically what we found here. And also, you can see that I followed this rounding requirement even for part A, right? Because that's round to the nearest cent, and that's what we were doing. And just here, you need to get rid of the dollar sign and then check my answer. So I guess that's it for this question.